Okay, so we're going to start with that one. And we're also going to start with sine of u minus v, which is the same exact format as this above line, but the plus sign is going to turn into a minus sign. So it becomes sine u cosine v minus cosine u sine v. And now, if we've got, they're kind of like maybe kind of view it like a system of equations almost. If I add these two sides, or this column together, that's going to look like this. It's going to look sine of u plus v plus then sine of u minus v is equal to, now add these things together. Add those two together. What do you get there when I add those two things together? Yep, 2 sine u cosine v. Need my u in there. What do I get when I add those two things together? 0. All right. So now I have, I'll multiply both sides by a half. Just the way you usually see it. So that this product has a coefficient of 1. So now you see, and like I said, this is called a product to a sum. So you're going to actually start with that side. Okay. So as I'm going through maybe a handout or going through a test or a quiz, it just says evaluate the next series of whatever, next series of expressions or equations, and somewhere I see like sine 2x cosine 3x. Now I see that sine u cosine v is that format where u is 2x and v maybe be 3x. Now I'm going to say, okay, rewrite that as a sum on the left-hand side. Does that make sense? Okay. So that this is kind of, I'm going to write one down and say, do an example with this. Let's go, say, sine of 5x cosine of 3x. Okay? So it just says maybe evaluate or simplify, something like that. Should say simplify for now. And I recognize, well, that pattern right there is that pattern there, where u is 5x. There's my u, and 3x is my v, right? Can we go through and now rewrite this then as 1/2. Now sine of u plus v. Sine of u plus v. Well, u is 5x, v is 3x. So becomes sine of 8x, right? And now plus then sine of u minus v. U is 5x, v is 3x, so subtract them, I get 2x. If you feel the need to do this, you can. I'm going to distribute that 1/2 through. Ultimately, it's not a big deal. You can write it that way. Okay. Now, somebody in the last class said, do we stop there? And for now, yeah, because right now I'm just trying to address how you take a product and change it to a sum, right? And you see then on the left-hand side, it was sine of 5x times cosine of 3x. And now on the right-hand side, it's a sum of two things. And those two things are different arguments than 5 and 3, right? 5x and 3x. But they should equate to one another. If we graph both those, they will lay on top of one another. They are the exact same graph. Somebody said, can I go further? Absolutely. Okay. If I start
with, I'm just going to write it this way real quick. All right, let's start. I guess we should do it down here. Is this a double angle? So can I rewrite this now as 2 sine x cosine x? That's what a double angle formula does, right? Okay. Plus then, now this thing's kind of ugly, but can't I take sine of 8x and say, well, let maybe u equal 4x. If u equals 4x, what's 2u equal? 8x. So now can I do a sine of 2u? And that becomes 2 sine u, or sorry, yeah, 2 sine u cosine u. And that turns into 2 sine 4x cosine 4x, right? Does that make sense, everybody? Well, now can I maybe let m equal 2x? Then 2m would equal 4x. So can I take this thing here, and I'm not going to go any further with this. Could I rewrite that as sine of 2m and then cosine of 2m? And now I have a double angle for sine, a double angle for cosine, and that should start to dwindle itself down to a singular angle. Does that make sense, everybody? Okay. Maybe at the start of class tomorrow, because we don't really have time to do this question, or to go any further with this today. We should, because of our use of double angle formulas, half angle formulas, our sum and differences, and now these, product sum and sum of products, we should be able to take any expression at any time, regardless of how big your arguments are, and dwindle them so that they become written in terms of 1x arguments instead of 2x or 3x or 5x or 8x. Does that make sense? It's a messy process, and there's a lot of substitutions, a lot of different formulas you have to use, maybe varying approaches. Okay, but that's one of the purposes for these things, because working with multiple angles, like a 4x or a 3x or an 8x, sometimes is hard. Okay, now dwindling them down to arguments of all 1x, that's hard too, but the payoff is that even though it's hard, it should be a little bit easier than dealing with an 8x. Okay. How can we check this? We should always be able to graph these things. Okay. So what do we start with? Sine of, was it 5x? Cosine of, was it 3x? Okay, so we start getting that kind of ugly curve, but you see that's periodic because that's what sine and cosine curves do, right? Now we're going to want to rewrite that and see, is that the same thing as 1/2 times, what do we have? Sine of 8x plus then sine of 2x. Does it give me the exact same curve? Yeah. Okay. So again, that's the check that you can use on these if you're simplifying. You want to see it, did they work out to be the same thing? What I started with and what I converted to, and indeed they do here. Another way of doing it is just choose a value for x. Okay. Let's say that x equals, let's go, instead of x, let's go a equals like pi over 6. Type that number in. Now, instead of using x's, let's use a's here. So a, evaluate. I'll have to cut that out here in a minute and paste it again and see what happens. But a, and then put a there. I'll cut that out. So let's see here. Control C. Control V. So it's just like using my TI 8384. Hit enter. It gives me 0 back. That should give me 0 back as well. and then see what happens when I start changing that a value. Let's say a goes to pi over 3. Were those numbers the same? Let's say a goes to 2 pi over 3. Are those numbers the same? Yeah. Okay. Because all that bar right there is doing is showing the height. Okay. If these were x's again. Okay, it's showing the height when a is at 2 pi over 3, so okay, it's showing that vertical, or sorry, that horizontal bar that's going through that point right there. Does that kind of make sense? Okay. So that's a product to a sum. Now, like the textbook says, the rest of these formulas are all developed in a similar manner. Let's maybe do one or two of those real quick. You would apply them or use them in the same way as what we just did with that example. But they're going to start off with these things again. Now, we just did addition of these two things, right? Which gave us that first formula over here. When I add those two things together, look at how these two formulas are very similar. Okay, if I've got sine u cosine v, and now this one here is cosine u sine v, well, I could write that as sine v cosine u if I wanted to. And now these two things are very similar. These two are very similar. But what happened? The arguments switched spots, right? Does that make sense? Well, how can I get that to happen? Well, look at what's different over here. Over here, 1/2 the same, sine's the same, u plus v is the same. That's different. Sine's the same, u minus v. Those are all the same. The only thing that was different over here was that was subtraction, right? So let's see that when we go through and do our work with this here, to get that subtraction on the right-hand side, it would be subtracting those two things, right? Okay. Then it would be subtracting those, and then subtracting those, right? And when you do this, you just got to kind of think about what subtraction is, okay? Because here we're going to have subtracting and negative, so we got to think about that in a minute. But now if I subtract these, it becomes sine of u plus v minus sine of u minus v is equal to, now these two things, what's going to happen here when I take sine u cosine v minus sine u cosine v? Yep, those go to 0. And now over here, what's cosine u sine v minus negative cosine u sine v? 2 cosine u sine v. Multiply both sides by 1/2. And now I've got that second formula, cosine u sine v. Okay. Even sometimes, guys, you might see in a problem that they might give you like 2 cosine of 3x sine of 5x. Okay. Well, that is exactly the same as this, right? It's just a kind of an alternate version, I guess, of this product of sum formula. Okay. So there I could rewrite this as, sine, if I'm looking at that 2 cosine 3x sine 5x, I could write it as sine of 8x minus sine of negative 2x. Does that make sense? So a lot, your formula in your problems that you see in your homework, the format that you're dealing with, if this is my example, it's not exactly like this one. You might see this You might see that 2 and think, okay, 2 sine x cosine x. Well, that might be a double angle formula. But what's the key thing for a double angle formula? What has to be true about those two things for a double angle formula? They have to be the same. And right now they're different, right? Okay. If I go through with finishing that example, we would rewrite this as sine of u plus v. So there's your u, there's your v, right? So it becomes sine of 8x minus now sine u minus v. And subtraction, the orders matters. So 3x minus 5x gives me negative 2x, right? Would you ever write it that way? Don't we know sine of negative theta is equal to the opposite of sine of positive theta? So can I write this as sine of 8x minus, now I'll write this thing as a positive 2x. So I need another negative out in front. So it becomes that. That's using this cofunction identity. But what's minus a negative? Positive. So sine of 8x plus then sine of 2x. And that is the same thing as that there. Benefit, I think one benefit is now cosine's gone. Another benefit is it's a product. Or this started as a product, now it's a sum. And another benefit is those are now both even numbers, aren't they? So if I wanted to go further, now they're both kind of in a double angle relationship. Okay. And when we say double angle, we mean ultimately multiples of 2. This could be 4, it could be 8, it could be 10. Okay. So then how do I get, if we look at the other 4, how do you think these other 2, how do you think these other 2 kind of get developed? Using the cosine sum and differences, right? So if you look at those, just write one of them out real quick, and then we'll get on to the other approach. If I have cosine of u plus v, you guys know that's cosine u, cosine v, minus sine u, sine v. And if I have cosine u minus v, that's cosine u, cosine v, plus sine u, sine v. If I add straight down, we'll get cosine u plus v plus cosine u minus v, right? What happens when I add straight down here? 2 cosine u, cosine v's. What happens when I add straight down there? Go away. Can multiply both sides by a half then? And there's the development then of my cosine u, cosine v, product to sum formula. Okay? And if you would have asked me, even if you asked me right now, even dealing with this for the last 2 hours of my life, if you were asking me, Mr. Fay, close your eyes, tell me what cosine u, cosine v is, I'm not going to do it right. I'm not going to know it. Okay? But if you ask me to close my eyes and work through the development of it, I'm going to be able to do that. And you should too. Okay? But you maybe not right now, because you want to do it for the last 30 minutes. But when you go home and you work on it and you derive it again, okay, and then you use it in your homework, and then tomorrow we derive it again in class, and then at night you go home and you work on it again, okay, in a couple of days, close your eyes, you should be able to derive it, and you don't have to memorize it, correct? Now the other ones, and I will, towards the end, I will let you write. I don't want to write these down right now because we're gonna waste time, class time. But I'll get these to you. If you still have that reference sheet from Friday, they're on that. But where do these come from? This is kind of working in reverse order of the last one. So these here are actually starting with these, but making a really, really, really nice substitution. So let's just start with one of those. Let's start with, Let's start with the first one. All right, so if I start with the sine of u cosine v, we said that that is the same as 1/2 sine of u plus v plus sine of u minus v. Okay. The development of our sum to product formulas. We're going to start over here with the sum of two things and see how that gets us our product over here. But a lot of times what's going to happen is that they're not going to be, so you're going to see something eventually that says like the sine of 4x plus the sine of 7x. And we should then be able to write that as a product of two things, okay? But we can't recognize because right now our u plus v is 4x and our u minus v is 7x. We can't necessarily real easily figure out what u and v individually are. Does that make sense? Okay? So this is what happens, and this is just a substitution that we recognize that's beneficial in this procedure. We let u be x plus y over 2. And we let v equal x minus y over 2. And we'll make those substitutions and see what happens. Okay, and so we'll make those substitutions over here on the right. Okay. And I guess on the left as well. So we get sine of u, which is x plus y over 2, cosine of v, which is x minus y over 2, is equal to 1/2. Now I'm going to go sine of u plus v. So u was x plus y. V is x minus y. They're both over 2. Minus x minus y. And now it's just simplifying, okay? Multiply both sides by 2. That's the first thing you probably should do. Makes it a little bit easier. A little bit cleaner looking. What's going to happen with the y's right here? They cancel out. And what are you going to get for your x's? 2 x's, right, up top? But it's all over 2, correct? So 2x divided by 2 is just 1x, right? What happens over here with your, so this becomes, it's minus this quantity, so it becomes plus the opposite of x, and the opposite of negative y, which becomes positive y. What happens with your x's here? Cancel out, and you get 2 y's over 2. What's 2y divided by 2? Just y. Now over here, nothing happens over here. But you see that convenient substitution of those two things made this side really nice looking, right? And that's the side that you're usually going to start with. If I have, let's just do an example. Let's say that they give me sine of 2x plus sine of 8x. That matches that format right there. Where this is the x in that format, and that's the y in that format, right? Doesn't that become 2 sine x plus y? What's x plus y going to give me? Gives me 8 or 10x, and then I divide by 2, right? So it gives me that 5x. And then cosine of x minus y. What's 2x minus 8x? Negative 6x. Divided by 2 becomes negative 3x. But here's the nice thing. What is the cosine of a negative theta? It's just cosine of the positive theta. So this actually can just become positive 3x if I want it to be. Okay. So how do we gauge whether we've done that correctly or that relationship should exist? We can come to GeoGebra. I had sine of 2x plus sine of 8x. Pretty ugly looking graph. Okay. Is that then the same thing as 2 sine of 5x times cosine of 2x? No, it wasn't 2x. 3x. Do those two graphs overlay each other?
Okay. So there may at some point be a benefit from going from maybe f of x to g of x, or from g of x to f of x. Okay, and that's one of the approaches that we can use to do that. Okay. Tomorrow, tie up any loose ends right now, 7-3, and then start solving equations, trigonometric equations.